Hello, this is the second in our video series for BMED 1111 and 3121. Once again, it's Dr. Saldivar. As a reminder, the purpose of these videos is not to take the place of a lecture, but rather to hit the high points to help you as a student understand what the major topics are that should be the focus of your reading. Thus, I would suggest you watch this video before doing the reading, if at all possible, or at least soon thereafter. You may even want to watch it twice to make sure you have a good grip on what these basic ideas are. If you can come in the classroom with what I would call a basic glossary level definition, if you're able to recall from memory a factual statement of what these different concepts are every week, I think you'll be in good shape. And then the purpose of our activities during class will be to help you expand upon your understanding and deepen it via the different activities that we'll engage in. Okay, so today this is the video for for January 22nd, the second of our class meetings. You had two chapters, very short chapters to read from our main textbook, which is by Glass. You also had two chapters to read in PDF form from a textbook on clinical research by Gallon et al. The main point to take away, well, there are two main points from the Glass text and three from the Gallon text. From the Glass text, there are two ideas that are very foundational to what will be our subsequent topics and discussions in the class, so be very attentive to these ideas. I admit Glass doesn't go into a lot of detail. His two chapters that we assigned are very short, but the idea is to introduce these ideas, these concepts to you at a very coarse level, at a low resolution, so to speak, and then sharpen that resolution, make the details finer grained as we go along. The first idea that Glass introduces is a branch of philosophy called epistemology. Epistemology is the study of knowledge. Our class is not a philosophy class, so I'm not going to go into the whole detail, into the history of epistemology. But the reason Glass raises this point, the reason we'll come back to it as we go through the course, is because everyone has a view of epistemology. Everyone has a way that they think about knowledge, even if they're not really aware of it, even if you don't have a label to put on it. If you've never heard the term epistemology before, that doesn't mean that you've never thought about these things. For example, and this example is not from your readings, but I want to try and help you think about this idea of epistemology. In my world of psychological research, and also in other areas of research, including, I know for a fact, public health, epidemiology, and other areas, one of the challenges that we face when we try and collect information from research subjects that is self-reported, like a survey. If I give you a survey, whatever the topic might be, a class evaluation, tell me about your opinion about this car that you're thinking of buying, talk to me about your alcohol drinking habits, whatever the topic is, but especially in topics that are seen as sensitive or might have negative connotations in society. There is always a danger when we ask for individuals to provide their data that's self-reported, to answer survey questions, where the individual basically is, we as the researchers are hoping, trusting that the individual is being truthful. Not necessarily truthful in the sense of not lying, although that's part of it, but also truthful in the sense of being accurate. There's a lot of evidence that human beings tend to misreport a lot of behaviors. The frequency with which we engage in certain behaviors, it turns out we are very bad at having an accurate count in our heads. Of, if I were to ask you, how many times have you greeted someone by name in the last 5 days? A question like that is very difficult for people to answer, even if you have otherwise a very good memory. We just are very bad as human beings at reflecting on our own behavior, even if it's a behavior we engage in frequently, even if it's a behavior that is very extreme, like I might consider substance abuse, drug use to be very extreme. Believe it or not, humans are very bad at recalling this kind of information. The point to all this is that because of this, the dangers, the limitations of self-reported data, you will encounter some researchers who don't like to use self-reported data, who will not consider it as part of their research studies because they just feel like, at least given a particular topic that they're investigating, that there's nothing to be gained. There's no benefit from using self-reported data because it's just not going to be accurate. As individuals who want to be medical professionals, healthcare professionals, you can see how this would be an issue, right? A lot of the information we have about drug use is collected by administering questionnaires and surveys to people. And thus things like the rates at which certain drugs are abused, a lot of that information, not 100%, but much of it comes from self-reported data. So if you are, let's say, an ER physician and you're trying to train yourself in that aspect of emergency medicine, how to deal with people that might be overdosing or having a negative reaction to substance abuse, to a substance that they're taking, how do you prepare yourself? If the statistics say X percentage of people in a given day are going to come into an ER with a substance abuse related issue, if that data comes from a self-reported source, are you going to trust it? Are you going to factor that into your planning as an ER administrator, for example? Or are you going to feel like, well, maybe I will trust it because of whatever reason, or maybe I'll split the difference and partially trust it, partially not? I'm glossing over a lot of ethical and philosophical issues here, of course, but again, my takeaway point, this idea of epistemology, this philosophy of knowledge, the way in which we think about knowledge, what knowledge is valid, what does it even mean to have valid knowledge. This is a deep issue, and we're not going to answer it in our class, nor are we going to cover all possible topics in our first presentation, in this next class meeting rather. But we're opening the door to this idea. So again, the takeaway point here is with epistemology, I'm going to argue, and we can discuss this in class, I'm going to argue that everyone has an epistemology. Everyone has some philosophy about the nature of knowledge, even if you've never put a label on it, if you've never consciously tried to engage with it. But this is one of the points that Glass is making, and we'll explore this further as a class. The second point that you need to think about that is raised by Glass in his chapter is his definition of science. Now, everybody who's ever written a textbook related to research methods, or even statistics, or philosophy of science, history of science, as well as, of course, many individual working scientists, everyone has a different definition of science. I'm not going to claim that Glass's is better or worse than others, but it's fairly straightforward and clear, and it's our textbook. So let's use, as a group, agree as a starting point at least to go with his definition. So Glass's definition of science is the determination of some property of a thing with a degree of accuracy that another person can confirm this property. If you have a certain thing, I like to use the term phenomenon, just some occurrence in nature. It could be a one-time occurrence. It could be something that happens repeatedly in nature. Cellular mitosis is a phenomenon. Lunar eclipses are a phenomenon. Just nerdy aside, phenomena is the plural of phenomenon. Just if you've never heard that before. So again, Glass's point, science, given a thing, given a phenomenon, there's some property of it that we measure, that we observe, that we perform an experiment on. We, as a scientist, as a researcher, do something to understand a property of the thing, to measure some aspect of it, as it were, and using the scientific method, recording our research method, recording the data that we capture from this experimental study, or any kind of study. Not all research is experimental, as we'll discuss. We develop a set of findings as well as a method for making those findings, which could be reproduced by someone else. And that's how science confirms itself. If I perform a certain experiment on a cell, the goal would be for me to tell another researcher, given a certain kind of cell, in a certain growth medium, in a certain aqueous solution, I mean, whatever all the details are that are pertinent, given all these environmental factors, given whatever steps I might have taken to prepare the cell sample, the tissue sample, I did X, Y, Z, and here is what I observed, or here are the findings. The idea is science is about reproducibility, and this idea of reproducibility will come up again and again during the semester. So if you've never encountered this concept, here's where we're opening the door. Science, the reproducibility of science is the way in which we confirm scientific findings. Whatever stuff Sir Isaac Newton found out about the speed of light, that's great, but it wasn't really accepted into science just because he said so, as brilliant a man as he was. It was accepted into scientific as scientific knowledge because he was able to share his method and his findings with other researchers who confirmed what he did, who reproduced his findings. All right, so Glass, epistemology, and then his definition of science, the two big takeaways from those readings. Obviously, you want to do the reading and fill in the details. The Gallon chapters, he raises, Gallon and his co-authors raise three important points. As you will read, they spend a lot of time in the two chapters talking about the history of medical research, or they use the term clinical research to focus on scientific research that looks at human systems, the human as a biological entity. The first of the three big points he takes away that I think is important, just philosophically for you to think about as a student, is medical research, clinical research has been a very basic, fundamental part of science research in general, as long as there has been science. Scientists have been concerned with what we would now call medical issues, clinical issues, just as long as they've been concerned about theoretical math or astronomy or basic physics and engineering that even in ancient cultures was used for various purposes. So we often talk about the role that science plays in the training and the development of medical professionals, but I think for those of you that aspire to be physicians or to work in the healthcare field, you can take pride in knowing that the reverse is also true, that science also owes a lot of many of its findings, many of the developments that have come in science come from researchers, scientists who had a focus on clinical issues, on issues of medical science. Second point that Gallon raises is a little more subtle, but it's something I wanted to highlight for you because I think it's important, and again, it's going to come into play over and over again during the course, which is the idea that scientific progress, even if we aren't really conscious of it, scientific progress tends to be very incremental. It's much more often a series of small steps, small moves forward in our advancement of knowledge. There are times when you have a giant leap forward, but those moments tend to be much rarer and much more due to random chance as much as they're due to some brilliant insight. Or maybe to put it another way, for every brilliant genius like Einstein and Newton and others who we can look to and see they made incredibly massive leaps forward in one field or another of science, there are many other scientists who aren't perhaps as famous, who didn't have giant leaps forward, but who also contributed in their own way, bit by bit, piece by piece, to the development of scientific knowledge. This is an important point to think about because I've had interesting discussions with students in the past where they raise the point that a lot of times in science education, generally, and I'm going back to your elementary school, middle school, high school, science education is often focused on the big obvious discoveries, because these are sort of milestones in the development of a scientific discipline. When you study physics, you study some of the big name Greeks, some figures from probably the Renaissance, some figures from the Enlightenment, and then a lot of more recent figures like the Faradays and the Lord Kelvins and the Einsteins. Um, and so it's easy to develop an impression as a student that it's these big names, these giant brains who are responsible for scientific progress, and of course they make a contribution. But the nature of science is such that often we move in smaller increments, and those smaller increments are not bad. Just as the giant leaps forward are not exclusively good, because everyone who makes a giant leap forward, even in a roundabout way, is building upon uh, the research, the foundations laid by someone else. Einstein's work in physics, for example, he explicitly if you look at his writing, he explicitly talks about ideas he got from other physicists who came before him, and he took their ideas and advanced them very, very far, but still he was building upon existing ideas. All right, so first point, or first 2 points from the Galen chapters, again, to reiterate, um, the close relationship between medical research or clinical research and basic science research all throughout history, and then secondly, the idea that scientific progress tends to be very incremental, which is not a good or bad thing. It just is the pattern that science usually follows. Final point, and this is going to be the subject of a lot of most of our in-class discussion, so I don't want to belabor this too much, but again, to raise a point before you do the readings. The second chapter from Galen in particular talks about the ethics of scientific research, and they cite a number of examples that they don't really explain in great detail. So I'm gonna go into a little detail here in this video. But first, just to make clear, the takeaway point is that we can take it for granted today that what we consider to be ethical research, it's natural to assume that this is sort of the way things have always been, when that is not the case. As Galen et al. Describe in their chapter, especially the second chapter that you're reading, the definition of ethical research, or even the idea that ethics are something we should care about, the idea that ethics even should come into play in scientific research, at least the way we think of ethics now, is a pretty new idea. And really the major milestones, the components of ethical research, which hint I would encourage you to specifically focus on and be ready to talk about in class. The components of ethical research, which are enumerated in this Galen chapter, are fairly new. I mean, really only 40, 50, at most 60 years into the past have scientists and others, government agencies, agencies that fund research, like the National Institutes of Health, the National Science Foundation, similar groups in other countries, only really since World War II have scientists, scientific community, government agencies, these funding agencies sort of come together over time and agree on what ethical research means. So these ideas are very new. We'll talk about this more again in class, but some of the examples that Galen cites, I would encourage you to look up if you're unfamiliar with them, especially the Nuremberg protocols and the discussion about research conducted by Nazi scientists during World War II. Again, I don't want to belabor this point here in this video. You can easily find less information on the internet. There are a number of good science websites, which I will link off of my homepage where this video is residing. But one example of how this ethical research has been developed, there were a number of studies, if you want to call them that. I mean, some researchers don't like to use the term because we're talking about a very horrible set of circumstances, but there were Nazi scientists who did research on concentration camp inmates, people who were locked up by the Nazi regime not because they had committed crimes, which doesn't mean, by the way, that if you are a criminal, you should be available for experimentation, because we ethically don't even have that view. But um, nonetheless, in particular, during the 30s and 40s, the Nazis locked people up not because of what they had done, but because of who they were. If they were Jews, if they were homosexual, if they were part of some minority that the Nazis decided that they wanted to eliminate from society. There were there was research done involving these individuals that they had no say over. They were just plucked out of from behind a barbed wire cage, literally in many cases, and subjected to all kinds of horrible uh, research studies, going from being subjected to extremes. For example, there are a lot of what was known originally by aeronautical engineers about the limits of physical stress on the human body. When when the militaries of the world, air forces, switched from propeller planes to jet planes, you had an exponential increase in speed, of course, right? Went from a prop plane to a jet plane. The G forces, the physical stresses on the human body, tended to be much greater. So there were concentration camp inmates who were subjected to being put in centrifuges and spun at multiple Gs until they suffered horrible injury. And that knowledge of, at 2 Gs, this tends to happen physiologically, at 3 Gs, this tends to happen physiologically, and so on and so forth. That information was gained by abusing people, sometimes often by killing people, and yet you could argue, and the argument has been made, that this knowledge, even though it was gained under horrible, objectionable circumstances that ethically we would not tolerate otherwise, is it possible that some of this knowledge, when applied by, again, aeronautical engineers or pilot trainers or whoever, could some of that knowledge help save people in other circumstances, even though it was gained under terrible conditions? That same line of research into applying stresses to the human body. There are records of Nazi scientists immersing people in freezing cold water to simulate what happens when a pilot or whoever has to abandon an airplane. You're flying an airplane over the North Pole or wherever, and you have to bail out, or you're a paratrooper, you have to jump out of an airplane in a frozen sea. And then you're immersed in cold water. Of course, you're going to become hypothermic very rapidly. How long does it take to be hypothermic, given your body mass, given your the amount of body fat you have, whatever other variables come into play? A lot of that knowledge originally came from these Nazi experiments. So again, the point is, these individuals who were, whether they wanted to or not, it was against their will. They were forced to sacrifice themselves for science. Note my sarcastic quotes. They were forced to sacrifice themselves for science under terrible circumstances, and yet it's possible or even probable that these horrible things that were done to them nonetheless produced knowledge that could help other people down the line. So these are disturbing examples, and my point is not to dwell on these horrible examples, as although I think it's important as researchers to understand why we care about ethics. It isn't just sort of something we say to go through the motions. It's because there have been unethical research studies many times in the past. They probably still happen today, but we as researchers, and certainly I would think as medical professionals, want to avoid causing injury in our pursuit of scientific knowledge. But the takeaway idea and the final point that Galen raises that I want you to think about is this idea that, again, the ethical line that we think of as existing now has shifted over time, first of all, but also secondly, even today, even with the knowledge, the experiences we've had, I would argue, and again, this will be something we'll discuss in class, I would argue that this ethical line is very difficult to draw. Reasonable people can look at the same body of evidence, look at the same conditions, set of circumstances, and often come to different conclusions, because at the end of the day, this philosophical choice is a very personal choice. Ethics are something that are so innate to us. we have sort of external guideposts, but it's difficult to have a true objective measurement that exists outside of us. So again, these are the kind of issues that we'll be engaging in our class discussion. So I hope this video has been helpful in terms of giving you some background information and helping highlight the 4 or 5 big ideas from these readings for this week that you need to focus on. Thank you for your attention, and I look forward to seeing you in class.